The receptacle located at the sump pit must be on a separate circuit breaker and branch circuit from a convenience outlet in the elevator machine room. This requirement stems from safety codes, specifically ANSI/SMA 17.1/CSAB 44-19 Safety Code for Elevators and Escalators, Section 2.10 and Section 3.2 Elevator Sump Requirements. Specifically, subsection C addresses the electrical requirements for the sump pit. It mandates that a duplex receptacle outlet, rated not less than 125 volts, 20 amps, and GFCI protected with a Class A GFCI device, must be provided adjacent to the sump pit. The crucial aspect here is that this receptacle outlet shall be supplied from a dedicated branch circuit, separate from the branch circuit supplying the elevator equipment. This separation is not arbitrary and serves several key purposes. Firstly, it enhances safety. A dedicated circuit for the sump pit receptacle minimizes the risk of electrical interference or overload affecting the elevator's operation. Elevators are critical pieces of machinery, and their reliable function is paramount for safety. Any electrical disruption could potentially lead to malfunctions, jeopardizing the safety of passengers. Secondly, it ensures the reliable operation of the sump pump. Sump pumps are designed to remove water from the sump pit, preventing flooding and potential damage to the elevator equipment and the surrounding area. By having a dedicated circuit, the sump pump is less likely to be affected by other electrical loads in the elevator machine room. This is particularly important during periods of heavy rainfall or groundwater intrusion, when the sump pump needs to operate continuously. Thirdly, it simplifies troubleshooting and maintenance. When the sump pit receptacle is on a dedicated circuit, it becomes easier to isolate and diagnose electrical problems. If there is an issue with the receptacle or the sump pump, it will not affect the elevator's electrical system, and vice versa. This reduces downtime and makes it easier to identify and resolve the problem. The requirement for GFCI protection is another critical safety measure. A GFCI, or ground fault circuit interrupter, is a device that detects ground faults, which are electrical currents that flow outside of the intended circuit path. Ground faults can occur when there is a short circuit or when electricity comes into contact with a grounded surface, such as water or metal. GFCI protection is essential in wet or damp locations, such as sump pits, where the risk of electric shock is higher. The GFCI monitors the current flowing into and out of a circuit. If there is a difference of more than a few milliamps, the GFCI trips, cutting off the power to the circuit. This happens very quickly, typically within milliseconds, which is fast enough to prevent serious injury or death. The specific requirement for a Class A GFCI device means that the GFCI must trip when a ground fault current of 6 milliamps or more is detected. This is the standard level of GFCI protection for receptacles in dwelling units and other locations where there is a risk of electric shock. The receptacle itself must be rated for at least 125 volts and 20 amps. This is to ensure that it can handle the electrical load of the sump pump and any other equipment that may be plugged into it. A 20-amp receptacle is also more robust and durable than a 15-amp receptacle, which is important in a potentially harsher environment like a sump pit. In summary, the requirement for a dedicated branch circuit separate from the elevator equipment, along with GFCI protection, is a critical safety measure that ensures the reliable operation of the sump pump, minimizes the risk of electrical interference or overload affecting the elevator's operation, and simplifies troubleshooting and maintenance. It is essential to comply with these requirements to ensure the safety of passengers and the proper functioning of the elevator system. When installing the dedicated circuit, it's important to follow all applicable electrical codes and regulations. This includes using the correct wire size, conduit, and overcurrent protection. The circuit should also be properly grounded to provide a path for fault current to flow back to the source, allowing the overcurrent protection device to trip and to energize the circuit. The grounding conductor should be connected to the grounding electrode system of the building. The overcurrent protection device, typically a circuit breaker, should be sized appropriately for the circuit. A 20-amp circuit requires a 20-amp circuit breaker. It's also important to label the circuit breaker clearly so that it can be easily identified in the electrical panel. The label should indicate that the circuit is for the sump pit receptacle. The location of the sump pit receptacle should be easily accessible for maintenance and inspection. It should be located in a place where it is not likely to be damaged by water or other debris. The receptacle should also be protected from physical damage by a cover or other means. Regular inspections of the sump pit receptacle and the GFCI device are essential to ensure that they are functioning properly. The GFCI device should be tested monthly by pressing the test button. If the GFCI does not trip when the test button is pressed, it should be replaced immediately. The receptacle should also be inspected for any signs of damage, such as cracks or corrosion. If any damage is found, the receptacle should be replaced. Furthermore, it is important to consider the specific requirements of the local electrical code and any applicable built-in codes. These codes may have additional requirements for some pit receptacles and electrical installations in elevator machine rooms. Consulting with a qualified electrician is always recommended to ensure that the installation meets all applicable codes and regulations. Proper installation and maintenance of the sump pit receptacle are essential for ensuring the safety and reliability of the elevator system. By following the requirements of ANSI/ASME A17.1/CSAB 44-19 and all applicable electrical codes, you can help prevent electrical hazards and ensure the safe operation of the elevator. Considering other factors such as the environmental conditions of the sump pit, using a weather-resistant or waterproof receptacle and cover is advisable. This will protect the receptacle from moisture and corrosion, extending its lifespan and ensuring its reliable operation. Additionally, it's important to ensure that the wiring and connections are properly sealed to prevent water from entering the electrical system. Using watertight connectors and conduit fittings can help to achieve this. The dedicated branch circuit should be run in its own conduit, separate from other circuits. This will provide additional protection against physical damage and electrical interference. The conduit should be properly supported and secured to prevent it from sagging or becoming damaged. The wire size for the dedicated branch circuit should be selected based on the ampacity of the circuit and the length of the run. Table 310.15b16 of the National Electrical Code, or NEC, provides ampacity ratings for various wire sizes. It's important to select a wire size that is large enough to carry the load without overheating. Overheating can damage the insulation on the wire and potentially cause a fire. The voltage drop on the circuit should also be considered. Voltage drop is the decrease in voltage that occurs as electricity flows through a conductor. Excessive voltage drop can cause equipment to malfunction. The NEC recommends limiting voltage drop to 3% for branch circuits. The length of the circuit run and the wire size can affect voltage drop. Using a larger wire size can reduce voltage drop. In addition to the receptacle at the sump pit, it may be necessary to provide additional receptacles in the elevator machine room for maintenance and testing purposes. These receptacles should also be GFCI protected and should be located in convenient locations. The number and location of these receptacles should be determined based on the specific needs of the elevator system. When selecting electrical equipment for use in an elevator machine room, it's important to choose equipment that is rated for the environment. Elevator machine rooms can be dusty and may be subject to temperature extremes. Equipment that is rated for these conditions will be more durable and reliable. Furthermore, it's crucial to implement a regular maintenance program for the electrical system in the elevator machine room. This program should include periodic inspections of the wiring, connections, receptacles, and overcurrent protection devices. Any damaged or worn component should be replaced immediately. The maintenance program should also include regular testing of the GFCI devices. Keeping accurate records of all maintenance and repairs is important. These records can be used to track the performance of the electrical system and identify any potential problems. They can also be helpful in the event of an electrical failure. Implementing proper safety procedures when working on electrical equipment in an elevator machine room is crucial. These procedures should include energizing the circuit before working on it, using appropriate personal protective equipment, and following all applicable safety regulations. Only qualified electricians should perform electrical work in elevator machine rooms. These individuals have the training and experience necessary to safely and effectively install and maintain electrical systems. Non-qualified personnel should never attempt to perform electrical work. Moreover, it's beneficial to provide training to elevator maintenance personnel on basic electrical safety procedures. This training can help them to identify potential hazards and avoid accidents. They should also be trained on how to test GFCI devices and how to report any electrical problems. Always consulting the manufacturer's instructions for all electrical equipment is an important step. The manufacturer's instructions provide specific information on the installation, operation, and maintenance of the equipment. Following these instructions will help to ensure that the equipment is installed and used correctly. Never modifying electrical equipment without the manufacturer's authorization is key. Modifying equipment can void the warranty and can potentially create a safety hazard. If modifications are necessary, they should be performed by a qualified electrician and should be approved by the manufacturer. Finally, ensuring that all electrical work is performed in accordance with the National Electrical Code, or NEC, is paramount. The NEC is a comprehensive set of standards for electrical installations. Following the NEC will help to ensure that the electrical system is safe and reliable. It's important to stay up to date on the latest edition of the NEC, as the code is revised every 3 years. These revisions may include new requirements for elevator electrical systems. Consider the benefits of using arc fault circuit interrupters, or RFCIs, in addition to GFCI protection. RFCIs are designed to detect arc faults, which are electrical arcs that can occur due to damaged or worn wiring. Arc faults can cause fires. RFCIs can help to prevent these fires by tripping the circuit when an arc fault is detected. While not explicitly required by the ANSI/SMA 17.1/CSA B44-19 standard for some pit receptacles, using an RFCI in addition to a GFCI can provide an extra layer of protection. Evaluate the potential for using surge protection devices, or SPDs, to protect the electrical equipment in the elevator machine room from voltage surges. Voltage surges can be caused by lightning strikes, power outages, or other events. Surges can damage sensitive electronic equipment. SPD can help to protect equipment from surges by diverting the excess voltage to ground. Although not mandated for the Sump circuit specifically, SPD can be a valuable addition to the overall electrical system. Be aware of the potential for electromagnetic interference, or EMI, from the elevator equipment. EMI can interfere with the operation of other electronic equipment. To minimize EMI, it's important to use shielded cables and to properly ground all equipment. Filtering can also be used to reduce EMI. Though the Sump circuit is unlikely to be a significant source of EMI, considering EMI during the overall electrical design is wise. Consider the accessibility of the electrical panel that serves as Sump receptacle. The electrical panel should be easily accessible for maintenance and repairs. It should be located in a well-lit area and should be free from obstructions. The panel should also be clearly labeled to indicate which circuits serve which equipment. Having a readily accessible and well-labeled panel simplifies troubleshooting and reduces downtime. Evaluate the need for emergency lighting in the elevator machine room. Emergency lighting is required in many jurisdictions to provide illumination in the event of a power outage. The emergency lighting should be powered by a separate emergency power source such as a generator or battery backup system. While not directly related to the Sump receptacle circuit, ensuring adequate emergency lighting is a critical safety consideration. Remember to document all electrical work performed in the elevator machine room. This documentation should include the date of the work, the name of the electrician who performed the work, a description of the work performed, and a list of any materials used. This documentation can be valuable for future maintenance and repairs. Accurate documentation also helps to ensure compliance with safety regulations. When upgrading or modifying an existing elevator system, it's important to review the existing electrical system to ensure that it meets current code requirements. This review should include an evaluation of the Sump receptacle circuit to ensure that it is properly installed and GFCI protected. Upgrading the electrical system can improve safety and reliability. Take note of any specific requirements of the elevator manufacturer. The elevator manufacturer may have specific requirements for the electrical system that are not covered by the ANSI/ASME 17.1/CSA B44-19 standard or the National Electrical Code. These requirements should be followed to ensure the proper operation of the elevator. Always prioritizing safety above all else when working with electrical systems is a must. Electricity can be dangerous, and it's important to take all necessary precautions to prevent accidents. Following all applicable safety regulations and using appropriate personal protective equipment are essential. Remember that a dedicated circuit for the Sump receptacle, separate from the elevator equipment, and proper GFCI protection are critical for ensuring the safety and reliability of the elevator system.